Here whenever architecture means IoT architecture concept is coming, then mainly sometimes we are getting confused that is it 3 layer, 5 layer, 7 layer, or what is the architecture. Actually the IoT is not specific that how many layers are there. There are different organization, they have their different structure or architecture. So there are 3 layer also where it is basic understanding. 5 layer normally for academic and exam perspective it is useful. 7 layer mainly for enterprise Cisco model. And IoT WF it is also following 5 layers which is normally industry reference. And 1 M2M, this architecture is functional entities, it is focusing on interoperability. So don't be confused about whenever they are asking architecture that how many layers are there. According to the requirement layers may change. Okay, that are the different types of architecture here. So main understanding as you can see here 3 layer, 5 layer and 7 layer where we are using. Now you can see the comparison between 3 layer, 5 layer and 7 layer. The basic purpose here, simple model, this is detail academics and it is enterprise and industrial. So what are the layers under these 3 layers? Perception and transport and application. These 3 layers available. Here when I am coming to 5 layers, then it is perception, transport, processing, middleware and application. So you can see there that how 2 new layer added here. Perception same, transport same, application same. In between these 2 layer added here, because I am going in depth little bit more because it is detail academic model. Now whenever I am coming to enterprise or industrial IoT, now you see here some new layer added like physical device. This is one new layer added. Connectivity, this is also another new layer added, and it is completely focusing on another part, that is edge computing, data accumulation, data abstraction and application business. So you can relate these two as a same type, and this is totally different because it is totally depending on enterprise version, that's why. So here perception, device layer, present, all are present here. Network connectivity, here transport layer, this is also transport layer, this is connectivity layer. Here edge computing, not in the 3 layer, it is not, 5 layer also not. Here explicit edge computing is present. Here data storage not defined, here processing, and here data accumulation. In this way you can remember these layers. Here also you can see that data abstraction. Here data abstraction not present, here limited, here data abstraction layer particularly present. Here middleware support not there, here limited, here implicitly it is there. Business logic no, here business layer different. Complexity is here low, medium and high, here scalability low, medium, very high. Latency optimization no, partial and strong in edge layer, because here edge layer is focusing on this latency. Here used in exam, normally basic question you are getting very frequent, and here competitive, because our focus is 7 layer, because in your syllabus also that's why they ask 7 layer. So don't be confused about that. Here real system rare, it is for academic purpose and this is for industrial purpose. So your question will be according to industrial purpose. Okay. Now see here, these are the detail already we have discussed. What are there? An IoT World Forum architecture. What is the focus of this? Device layer, gateway layer, data management layer, application layer and business layer. Sometimes some question will make you confused that these are the layer present, why this layer is not present, because which architecture, according to which architecture question came, there you have to focus. That's why don't be confused. When it is coming to the 1M2M architecture, then it is focusing on these entities. like common service entity, application entity, network service entity, and focuses on interoperability. This is completely different. It is not focusing on those 3 layer, those 7 layer. It is completely different. It is focusing on different entities, right? Got it? So I hope after this year all the confusion will be over for different architecture and different layer. Whenever question will come, you can do it. Yes? No confusion? Now you see here, we will see the detailing for IoT versus M2M versus CPS. This comparative analysis is required. What is actually the difference between them? Okay. So here IoT means, normally we know that it is focusing on the connectivity with the devices. So system enabling the intelligent service using the connected physical object, that is IoT. Then what is M2M? It is direct communication between machine without human involvement. In IoT, human involvement is required because we are touching, we are giving that signal, then only it is working. But M2M, it is directly machine to machine. That's why human involvement not required here. CPS, it is integration with computational algorithm with physical processes through the feedback control. So it is more advanced. Here you have feedback control and the computational algorithm also there. So one by one, M2M is simple, CPS is control centric, and IoT is internet centric and intelligent also. This is the main difference. Now where I am using, what is the main comparative study? Here you can see internet aspect, IoT yes, M2M not mandatory, CPS sometimes. So for IoT always internet is required. Intelligency, high intelligency, here low intelligency, here also high. Scalability very high, here it is limited and here it is medium. So I hope this CPS, IoT and M2M is clear to everyone, right? Yes. Okay, now you see little bit more detailing about this. Here already we have done the definition. It is physical object connected through the internet for data exchange, intelligent services. This is direct communication without human, and this is tight integration of computation, networking and physical process. That's why it is called CPS. Internet dependency mandatory, not mandatory. Here communication many to many, one to one or few to few. Here closed loop feedback. This is there. Keywords remember so that you can do the question. I will ask you question. Those who are not listening, they will be not able to do the question. Just now I will ask you question. So please listen to me. These are very important. After doing so many analysis, I am giving you this type of comparative study so that you can get marks in exam. So please don't ignore. Okay. Here you see. The intelligent level, high, analytics, I, AI, cloud. ওকে এ মা ফোন করছে ধরতে হচ্ছে বলতো বাবা ক্লাস নিচ্ছি yeah sorry my mother was calling sorry. So here low rule based and very high control centric. Scalability is very high, limited, medium. Human involvement minimal here. Here no, here also minimal involvement required. Remember that in M2M no human involvement. Next one, real time constant. Here real time, what are the constants? Soft real time, it is limited, and it is hard real time. Data processing on cloud, edge and fog. 3 types of computing is there in IoT. Here only in local system. Here it is embedded and real-time controller where I am working. Decision making, data driven and analytics based. This is predefined logic and this is control theoretics. Feedback loop only here, mandatory. Here no feedback loop, no feedback loop. Here example, smart city, smart home, healthcare. Here smart meters, vending machines. Here autonomous vehicle and smart grid. Examples very important. They can ask you example and they can ask you question ki according to this one, which one I should apply, means which application, IoT or this or this. Like that you can get the question. Complexity is high, low, very high. Here security, high concern, moderate, critical. Clear? I hope this concept is clear. Then tell me the question. Here three, one by one I am asking you question. You have to give me the answer. Tell me the answer. Quickly give me the answer. As I am not giving poll, you can give me the answer in the chat box, because giving poll it will take time. I will try to complete the class quickly. Yeah, one by one give me the answer. Good. Which system strictly require the feedback control loop? After that, next question, I will show you the answer. Which of the following not required internet connectivity? Good. Scalability is the high. Scalability is high in where? Good. Next. Hard real-time constraints are mainly associated with what? Yes. So here you can see the answer. Which strictly required the feedback control loop, that is CPS. Which following not internet, that is M2M. Here scalability is high in IoT. Real-time constraint mainly associated with CPS. So now tell me, do this. Which IoT architecture introduce a processing layer explicitly? From the architecture, different types of architecture just now I tell you. Yes. Next one M2M mainly focuses on good. So here your answer is, this is 5-layer architecture and this is M2M mainly focuses on interoperability, right? This is like a learning. Whenever you are learning, after learning you just try to solve the MCQ, yes I am able to recall or not, then it is entering in your mind, otherwise it will not enter in your mind, especially when this is theory, right? Now see, here these are the enabling technology of IoT. RFID, that is identification and tracking. WSN, distributed sensing. Cloud computing, storage and processing. Big data, data analytics. IPv6 for huge address space. And CPS, physical plus computational integration. These are the main technique what we are using in IoT, right? Here, now tell me the answer from this. Which technology enable unique identification of the object? Yes. Next, IPv6 important in IoT because good. So here RFID, right? Just now I told you unique identification, and this is IPv6. Here large address space because of this. Now see, here now we will see that this is examiner's favorite topic, that is MQTT and CoAP, right? So MQTT is very important. So learn the topic in detail, which is most important for you. Okay. Are you feeling boring or interesting? Are you getting confident that okay, I will be able to get question and I will be able to do the answer for IoT? Till now, maybe day before yesterday also you have not learned, you did not learn this IoT topic, and now you are getting confidence that yes, I will be able to do. Okay, good. That's important. That's really important for you. Okay, good, good, very good. So now see, MQTT, message queuing telemary transport. What is this? MQTT means, MQTT is lightweight, publish subscribe. Yesterday we saw this keyword, right? What is public subscribe? Now we will understand. Public subscribe messaging protocol designed for resource constrained device and low bandwidth, high latency, unreliable network. All the keywords together. For MQTT, these are the main keywords where we are using, why we are using, and what is the purpose. So developed by IBM, standardized by Oasis, widely used for IoT application. Now why MQTT required in IoT? Because very low protocol overhead and efficient for battery power devices, because battery power is a big problem here, and work all over the unreliable network, because all are not reliable. So many unreliable network can be there. That is a biggest feature, that it is working in unreliable network also, and support the asynchronous communication. MQTT communication model, how? Publish subscribe model. What is the meaning? Publisher means the send message. Publisher is the sender. It is sending the message. And subscriber means receive the message. Just like that, this is sender and this is receiver. But we are calling it publisher and subscriber. There is in between broker is also there. What is the task of broker? Broker is central server that manages the communication. Okay, just like that, you are going to purchase any flat or you are going to take a rent of the flat. Sometimes in between the brokers are there who is making the communication, right? So here, publisher and subscriber do not communicate directly. Through the broker only connection will be there. That's why in between broker is there. Okay. Now MQTT architecture components. This is the component: publisher send message to a topic. Subscriber subscribe to the topic of interest. Like I am launching a course. I am sending the message. Okay, this is the course available now. Now if you are interested, then you will subscribe. Just like that. Right, we are uploading any video. After watching the video in YouTube, you are subscribing the channel. So just that type of concept. If you are interested, then you will subscribe. Okay, got it. For publisher Priyanka ma'am, subscriber me, broker Unify Study. Yes. Exactly. Great example, Purnima. Exactly. Whenever you are searching for any topic, you are getting that topic. Yes, Priyanka ma'am is teaching here in Unified Study channel. Then you are subscribing the channel. Exactly. Yes. Now broker. Broker is the receiver message and distributed them to the subscriber. Right. Now here, this is the topic. What is the topic here? Here, UTF-8 string used for message filtering, means whatever message is sending, it is giving that through the UTF message string. Example, home room 1 temperature. Like it is able to sense the temperature. Now after sensing the temperature, it is sending a message. Okay. Yes. Now MQTT protocol stack. Here these are the stack. Here application, transport, security and network. Application, that is MQTT. Transport layer, it is using TCP. Very important, remember that. Already question you saw yesterday. Security, either TLS or SSL. and network IP address. It is working with IP address, not MAC address. MQTT does not work in UDP, remember that. And MQTT message structure is fixed header, variable header, both can be, and payload. Now you see here, this is the quality of service, very important. Quality of service level guarantee. Here the description you can see, this is quality of service level 0, at most once, no acknowledgement. 1, at least once, that acknowledgement required. And 2, exactly once, high reliable. Very important, remember that these are the QoS level. This is QoS 0, this is QoS 1, this is QoS 2. This is at most once, at least once, exactly once. Remember, note it down. So, how to memorize means how to relate. Higher QoS means higher overhead. Whenever you are coming to 0 to 2, here higher overhead because highest reliability. That's why it is high and this is low. Okay, you can remember like this way. Here this is MQTT control packets. Connect acknowledgement, publish, subscribe acknowledgement, unsubscribe, disconnect, and ping gray queue means you are getting the acknowledgement queue, and here pin grace SP. Okay. Now here MQTT features. This is lightweight protocol, bidirectional communication, session awareness, written message, and last will and transmit, that is LWT. This is the full form of LWT. Last will and transmit. Testament, sorry, transmit not. Last will and testament. That is LWT. Now see the difference. See that through the HTTP also we can send the message, right? Then why MQTT required? And what is the main difference? Because normally we are using in web HTTP www.unifiedstudy.com. Then why this is required? Here the communication model is request and response, and here it is publish and subscribe. This is also using TCP, this is also using TCP. Overhead very low, here overhead high. Here low power consumption, here high power consumption. Stability, suitability for it is excellent, it is limited. Because mainly in IoT, power is a big problem. As it is using low power consumption, even also overhead is very low. That's why MQTT is the best choice for IoT. This is the main advantage of MQTT: low bandwidth, low power, scalability, and reliable message delivery. Limitation: require broker. In between broker is not there, then you cannot communicate. And not ideal for the large payload, less human reliable than HTTP. These are the limitations of MQTT. Clear? MQTT concept clear? I will go for question. Ping request or response? Yeah. That was ping request or response, Indumati. PING request and PING response. Ping request and ping response. That was there exactly. Just now this one. Where it was? Ping request. Somewhere it was there. Last one. This is ping. You are going to ping request and ping response. Ping means you are ping me in WhatsApp. You are telling, right? Ping me in WhatsApp. That is that ping. Yeah. Now can I go for question? Tell me the answer. Question in front of you. One, two, three. Three questions are there. You can give me the answer with 1, 2, 3 like that. Okay. Fourth one. Fourth one. Okay. Good. So your answer is this one. MQTT follows which communication model? That is publisher subscriber model. MQTT mainly runs over TCP. Which MQTT component acts on intermediary? That is broker. Which QoS level guarantee exactly once delivery? That is QoS 2. Option C is the correct answer. Clear? Now next question, you can tell me MQTT most suitable for 5 and 6. Question number 5 and 6. Give me the answer with number, then it will be easy for me to understand. Okay. Okay, good. Yes. Here is your answer. MQTT most suitable for resource constrained devices. Option B. And topic of MQTT used. Which one? That is message filtering. Option B. Right. Now see, then what is CoAP? That is another communication medium. What we are doing? CoAP. CoAP means, here you can see here, CoAP is Constraint Application Protocol. Constraint Application Protocol means, what is CoAP? CoAP is lightweight REST based application layer protocol designed for resource constrained IoT devices and low power lossy network. Okay, where we are using mainly lossy network. That is a main focus here. Low power, both are using protocol here also. Resource constraint, this is also another one. Means according to the situation we will choose. Here developed by IETF based on REST architecture, and it is optimized for UDP, not for TCP. MQTT working on TCP and this is working on UDP. Why CoAP used in IoT? What is the requirement here? Here low overhead, suitable for battery powered devices, work efficiently in lossy network. This is the main target, lossy network, and easy to integrate with HTTP. Here MQTT is not similar as HTTP, but this is similar as HTTP, and that's why easy to integrate with HTTP. That is the advantage here, because normally previously we are using HTTP, we are habituated with HTTP, right? So here it is working with request response model. MQTT work with publisher and subscribe model. Here similar to HTTP, client send the request, server response. Unlike MQTT, CoAP does not use publisher subscribe, publish subscribe model. This is not using it. Okay. Now here, this is the stack. What are the stack we are using here? Layer, protocol, application, CoAP, transport, UDP. Security, it is using DTLS. There we saw different and here we saw different. Remember that. What security we are using? Network also IP. Okay. The key difference you can see between MQTT and the key difference is here MQTT use TCP and CoAP use UDP. The message format here 4 byte header, token, option, and payload. Here it is small fixed header and low overhead. Okay. CoAP methods, what are the same methods as HTTP? HTTP GET request we are sending, right? HTTP GET and POST. Same method we are using, GET and POST. Put and delete. All are the same method just like HTTP. And here CoAP message type. What are the types are here? What type of message? CON, that means confirmable, require acknowledgement. NON, non-confirmable, that means no acknowledgement. And ACK, that is acknowledgement, and RST, that is reset message. Remember these two, very very important. What types of message are there? Even also these four also they can give you option. Few part of the message are available in CoAP. So here these are the feature of CoAP. Restful design, low bandwidth use and asynchronous communication, resource discovery, built-in multicast support. Advantage is very lightweight, it is easy for HTTP integration, support multicast, it is also a big advantage, and efficient for LLN. Okay, what is the limitation here? Limitation is less reliable than MQTT and no non-native publisher subscriber model, security via DTLS, add-on overheads. These are the limitation of CoAP. Here you can see they are very common with HTTP, mostly common, but here is one difference is there. HTTP working with TCP, but this is working with UDP. That is the difference, remember that. Here it is very low, overhead high, application managed, here TCP managed. Who is managing it? Application, and here TCP is managing. Power consumption low, here it is high. It is excellent for IoT and it is limited. So that's why in IoT we are using communication model CoAP and MQTT. Where UDP required, there you can go for CoAP. Where TCP required, you can go for MQTT. Right. Here it is very important difference between your MQTT and CoAP. These are the feature: CoAP, MQTT, request response, publish, subscribe. This is UDP, this is TCP. Here broker not required, here it is required. Latency very low, here it is low. Reliability optimal, here it is QoS best. Because QoS is more means reliability more. Here it is device to device, here it is many to many. That is also must remember. It is working on many to many, it is working on device to device. Okay, difference clear? So you are able to relate what is MQTT and what is CoAP. Yesterday I gave you just introduction and now I am giving you in depth of each and every topic. Clear? I hope no doubt. So here you can see this. This is lightweight, publish, subscribe, TCP. These are the level, and this is RST based, UDP, low overhead, use constraint devices. Here main difference between HTTP, MQTT and CoAP. This is TCP, TCP, UDP. Request response, publish, subscribe. This is also request response. Overhead high, low, very low. This is the main difference between HTTP, MQTT and CoAP. Clear? Pakka clear? Now prove that it is clear. I am very bad. Whenever I will tell you, then there I will ask you questions so that you can relate the concept. I will not allow you to sleep in my class. No sleeping. Okay, good. Answers are coming. 3 and 4. 3 and 4. Okay. So here is your answer. CoAP standardized by IETF. CoAP mainly run over UDP. Which communication model CoAP use? That is client server model. Which CoAP types acknowledgement? That is CON. Right? Yes. Now confirm. CON means confirm acknowledgement. Now here come to the security. IoT security, word from where you are getting repeated questions. So why security required? What are the challenges? What are the techniques we are using here? All that we will see. So security challenges, IoT security is more complex than the traditional IT because resource constraint is there, low power, memory, CPU and massively distributed, often deploy in untrusted environment. It is heterogeneous, different vendor protocol. Here you can see the security goals for IoT. Security issue, authentication, authorization, confidentiality, integrity and availability. These are the main goals. Now where it is focusing, that is most important for you, the goal. These goals are your security. Confidentiality, prevent unauthorized data access. It is not only for IoT, this is important throughout the computer science. In networking also it is required, database also it is required, network security also it is required. Very, very important. This chart is 99.99% chance you will get one question from this chart. TRB also, call UGC net also, SET also. So it is very important chart for you. Confidentiality, prevent authorized data access. Integrity, prevent data modification. Availability, ensure continuous service. Authentication, verify device or user identity. Authorization, control access right. And non-repudiation, prevent the denial of action. Must remember, very important for you. Okay. Here these are the comparative study on IoT and traditional IT security. What is the requirement? Here it is powerful computers required. Here resource constrained devices required in IoT. Network is stable and reliable. It is unreliable and lossy because whenever you are using IoT, then mostly network is unreliable and it is lossy. That is a challenge here. Scalability limited, here massive, too much scalability. Power continuous, here battery powered. Here security mechanism, heavy encryption like RSA or AES. Lightweight cryptography we can use here. Updates easy, here updates are difficult. Attack surface limited and here it is very large. Anywhere it can be attacked. That's why IoT security is more challenging. Okay, IoT security cannot directly use the traditional security mechanism because of these problems. Now here layer wise what type of security is required, here you can see. In IoT layer, perception, that is sensor. So here security threats can be node capture or fake nodes. Some fake nodes can come, node can be captured. This can be a security threat here. So what mechanism we can use here? Lightweight encryption and physical security. Transport or network, that is DOS, and eavesdropping, that type of threat can be there. Security routing or DTLS, we can use this mechanism. Here under processing, cloud or fog. Here data breach or malware. That problem can happen. We can focus on access control and encryption. Application layer, unauthorized access can happen. So that's why authentication and authorization required. Got it? Layer wise security thread and security mechanism, which one where applicable, that is important. Clear to everyone? These are the attacks. DOS attack, replay attack. We learn it in network security also. All subjects are related. Means now whenever you are coming to advanced topic, you will see that looking like different units, but actually everything related. Here these all attacks. DOS, replay attack, spoofing and man in the middle. These are the attacks may happen in IoT. Now let's see what are those attacks and what is the comparative study between these attacks. Attack type DOS, it is focusing on availability. Detail I provide already network security notes. Watch it and check that. Availability. Effect service disruption. Spoofing, it is target is authentication, fake identity. Replay attack, target is integrity, reuse of valid messages. Man in the middle, focus on confidentiality and data leakage, it is the effect. Node capture, physical layer, full device compromise. Very important chart, high chance you can get question from here. Very important, must remember. I tried to make it as crisp as possible, and what is the main focus? On that main focus only I am trying to give you, so that at least you can do your best in exam and you can come out from exam hall with smiling face. That smiling face I want to see. Yes ma'am, so many things I am able to do, because this type of mind mapping will help you. Okay, it is very important for you, must remember which one is focusing on where. Here it is the comparative study for the IoT security protocols. Different protocols we are using now. TLS, transport layer, strong encryption and heavy overhead. DTLS, it is using for transport in UDP. Secure CoAP, energy consuming. IPsec, that is for network and end-to-end security, and it is complex one. Lightweight cryptography, normally device layer, low power and low strength also. These are the different types of security. Okay, Priya 33B. I did not ask any question now, Priya. I think Priya is not in live. Priya is watching little bit delay, maybe. Clear? Comparative study of security protocols. And here is the comparison of security protocols between MQTT and CoAP. This is TCP, UDP. This is using TLS and SSL. This is using DTLS. Authentication, username, password. Here pre-shared key and certificates. Overhead medium, here overhead low. Here it is cloud centric IoT, here it is constrained IoT. Yesterday we learned constrained IoT, right? This is the two different security focus. Here these are the challenges versus solution. Limited resource, we can go for lightweight cryptography. Device authentication, for that PKI or device identity. Scalability, automated key management. Data privacy, end-to-end encryption. Physical access, tamper resistant hardware. This can be the main focus. Okay, your security is done. With this your security part is also done. Ready for question? I told you, right, I will not waste your time. I will invest more time before class, but in class I will not waste your time. One thing only telling repetitively, stretching it like a bubble gum. I don't like that. I will take your class so that your all topic will be done quickly and you can go and enjoy. Do that. Now do this. Question, answer. Which security goal is violated in DOS attack? Second one, 1, 2, 3. 3 questions are there. Okay. Third one. Which protocol secures CoAP? Okay, good. Fourth one. Node capture attack mainly affect which layer? Okay, good. So here your answer. Which security goal violate DOS attack? That is availability. Why traditional security algorithm unstable? For because resource constraint. Here which protocol secures CoAP? That is DTLS. Node capture attack mainly affect which layer? Perception. Now here are the some little bit next level question for IoT. Tell me the answer. Read question carefully, then answer. Not direct, little bit indirect. Think and answer. Think and answer. 1, 2. Second one. Okay, good. Third one. Third. Okay, good. So here your answer. Why DTLS preferred over TLS in CoAP? Because DTLS work over UDP, which reduce the protocol overhead. Next one, an IoT system use the edge computing for the process sensor data locally, which security advantage does not primarily provided, that is reduce attack surface. Option C. Here third one, which scenario best illustrated for replay attack in IoT? That is attacker resent a previously valid authentication message. Option C. Next question, 4 and 5. Question number 4 and 5. Read and answer. Okay, 4, 5, 5. Okay, 5 is also answer coming. Very good. 6, 6, 1. Okay, good. Good. So here your answer. Why lightweight cryptography preferred over RSA in most? Because here IoT devices are limited in power. Power is a big factor here, right? Now, fifth one here. Which IoT security property is mainly compromised with a node capture attack? This is all of the above, because availability, confidentiality and authentication all are focusing here. Next one is sixth one. MQTT enables the QoS to primarily improves which security related aspect? That is integrity. Next one, 7 and 8. Okay, very good, very good. You all are giving answer very nicely. So IPsec rarely used in directly constraint of IoT because it's introduced high computation and memory over it. That's why. And here eighth one, which design best improve for end-to-end security? That is layer wise security implementation. Next, 9 and 10. Two more questions. Okay, good. So here an IoT healthcare system prioritize the data confidentiality. Which approach is most appropriate here? That is use the symmetric encryption with the key management. And 10th one, which system best distinguish for IoT security from the most one? That is IoT security require the lightweight and scalable mechanism. So option B is the correct answer. So with this one, your 1 hour, I think in 1 hour you learned so many things. Yes or no? Tell me. How was your last 1 hour? Is it utilized properly? Last 1 hour utilized properly? I did not ask you in poll. I think near about more than 30 questions I ask. I think more than 30 questions I ask you, and topics also I covered. I will not waste your time, as I told you, right? I will not waste your time. I will come, I will give, and I will do. Okay. Yeah. Thank you. Thank you so much. So behind this 1 hour, there is lots of effort required. Because why? Background I am trying to put your effort, because before exam, whenever you are revising, quickly you can revise and you can get so much knowledge with question, and you can go for exam and you can do it properly. So please come, go to your exam. Definitely you are here because you are preparing for some exam. Go for exam and let me know, then let me know, come back that yes ma'am, my exam was good in this IoT topic. We did so many questions. Yes, these are the question came. That is a one request. After coming back from exam hall, definitely come back here and comment here. So please like, share, subscribe and stay tuned with this channel. Thank you. Bye. See you soon in my next video.